All right, get ready, because today we're diving deep into something pretty wild, this idea of longevity escape velocity.
Longevity escape velocity.
Yeah, it's like, what if science could make us live longer, like way longer, faster than we age?
So we're talking about outrunning aging itself.
Basically. And the crazy thing is, it's not just some sci-fi fantasy anymore. Scientists are making some actual progress in areas like using AI for drug discovery and even tackling those things that make our bodies stiffen up as we get older.
It's certainly a hot topic right now, and it's definitely more than just theoretical at this point.
I know when I first started reading about this, the whole AI thing really blew my mind. Like, scientists are using AI to hunt down those compounds that could help us live longer.
Oh, absolutely. It's not just about speed either. It's about finding totally new ways to approach the problem, things we might have missed completely otherwise.
It's like having a superpowered detective working around the clock.
That's a great way to put it. Take, for example, how they're using AI to predict the 3D structure of proteins.
Proteins. How does that help us live longer?
Well, understanding the structure of proteins is super important for figuring out how they age.
Oh, I see.
And once you know that, you can start designing drugs that can actually target those specific proteins and maybe even slow down or reverse the aging process.
So instead of just throwing darts in the dark, we can use AI to actually pinpoint the stuff that has the best shot at working.
Exactly. And this isn't just happening in drug discovery either. Yeah. Scientists are also looking at ways to deal with, that stiffness that seems to come with getting older.
Yeah, like our bodies slowly turning into, I don't know, a tangled up rope or something.
Yeah, kind of. But the good news is researchers are really zeroing in on specific enzymes like lysyl oxidase.
Lysol, what now?
Lysyl oxidase. It's an enzyme that plays a big role in that whole cross-linking process that makes our tissues stiffen up.
Ah, okay.
And they're experimenting with these things called inhibitors, which can actually control how active these enzymes are.
So they can like dial down the stiffness?
Potentially, yeah. It could mean slowing down or even reversing the stiffening of our tissues, which could have huge implications for things like heart health and even vision problems that come with age.
Wow. So instead of just accepting stiff joints and clogged arteries as part of getting older, we might actually be able to do something about it on a molecular level.
It really is remarkable, isn't it? And it all points to this really crucial idea. Aging isn't just one single problem, it's a whole bunch of processes happening all at once.
Okay, so let's break that down a bit. I think this is where the whole longevity escape velocity thing comes in, right? LEV.
Exactly. Aubrey de Grey, he's the one who really popularized the term.
Okay.
And the basic idea is that for every year that goes by, science should be able to add more than a year to our lifespan.
So it's like a race against time where science is trying to stay ahead of the clock. But is that even possible? I mean, aging is like so complicated.
It's definitely a big question. And right now, LEV is still, more of a theoretical idea. We can't say for sure if it'll happen in our lifetime, but the stuff we're seeing, it's pretty promising.
So there's hope.
Definitely. And that leads us to some of the really exciting strategies that are driving that hope for LEV.
Like what?
Well, one of the things that really jumped out at me was this idea of a divide and conquer approach to tackling aging.
Divide and conquer. Sounds kind of aggressive.
It is, in a way.
Hmm.
Instead of looking for this one magic bullet to cure aging, scientists are realizing that we need to tackle all the different parts of it at the same time.
So more like a team effort, right?
Exactly. Like a team of specialists, each one focused on a different piece of the aging puzzle.
Makes sense. So it's a much smarter approach than just hoping to stumble across a single solution.
Absolutely. Some researchers are really focusing on mitochondrial dysfunction.
Mitochondrial what now?
Dysfunction. It's basically when our cells don't produce as much energy as they used to.
Oh,
And then others are looking at cellular senescence, which is when cells basically stop dividing and just kind of hang out, but they don't actually die off.
so they're just kind of taking up space. Not helpful.
Right. And then there's all this research on ways to boost our immune systems, which tend to weaken as we age.
So it's like a full-on assault on aging from every angle. Sounds promising, but I'm guessing there are also some pretty big roadblocks on the way to this whole LEV thing.
There are, for sure, and we'll get into those in a bit. But first, I think it's worth exploring some more of this exciting research that's happening right now.
Okay, what else is going on?
Well, one area that's showing a lot of promise is this research on something called senolytics.
Senolytics. That sounds kind of like science fiction or something.
It does, doesn't it? But it's actually pretty fascinating stuff. Remember how we were talking about those senescent cells, those cells that enter that zombie state where they're not really doing anything useful, but they're not dying off either?
Yeah, the ones that just kind of hang around causing trouble.
Well, it turns out that these senescent cells can actually build up as we age, and they can actually contribute to like inflammation and damage in our tissues.
So they're not just being lazy, they're actively making things worse.
That's right, and that's where senolytics come in. It's a whole class of drugs that specifically go after these senescent cells and eliminate them.
Like a cellular cleanup crew.
Yeah, exactly. They basically clear out all that cellular debris that can make aging speed up.
That sounds amazing, but I'm guessing it can't be that simple. Are there any downsides to this approach?
Well, one of the big challenges is making sure that these senolytics are really good at targeting only the senescent cells. We don't want them accidentally taking out healthy cells in the process.
Right, that wouldn't be good.
Huh.
So there's still work to be done to make these drugs as precise as possible.
Exactly. And then there's also the question of what happens in the long term. I mean, the early research looks great, but we need more studies to really understand how senolytics might affect the body over, years and years.
So it's all about balancing the potential benefits against the risks that we might not even know about yet.
That's a great way to put it.
Yeah.
Which brings us to the other side of this deep dive, the hurdles we still have to overcome if we want to reach LEV.
Okay, what are we up against?
Well, I think one of the biggest hurdles is simply how complex aging is. Even if we make a big breakthrough in one area, it doesn't mean we figured out the whole aging puzzle.
It's like trying to fix a leaky roof, but every time you patch one hole, another one pops up somewhere else.
Yeah, kind of. We have to get to the root causes of aging in a way that's really comprehensive, and we're still working on getting there.
And I imagine the whole regulatory process for new therapies is another huge hurdle. You can't just invent a new drug and start giving it to people the next day, right?
Absolutely not. Even if a new anti-aging treatment works amazingly well in the lab, it still has to go through all these tests and clinical trials to make sure it's both safe and effective.
Right. Got to make sure it actually works and doesn't cause more problems than it solves.
Exactly. And this whole process, it can take years, sometimes even decades.
Wow. So it's not just about the science, it's about navigating this whole maze of regulations and approvals, too.
That's a big part of it.
Hmm.
And then there's the whole question of access. Like, even if a new therapy gets approved, will everyone be able to get it, or will it only be available to, people who can afford it?
That's a really important point. We want to make sure that these advances benefit everyone, not just a select few.
Right. And then there are all the bigger societal implications to think about. Like, what would happen if people started living a lot longer? How would that affect our jobs, our healthcare system, our families?
I know, it's crazy to even think about. Like, imagine a world where people live to be 150, 200 years old.
It would definitely shake things up a bit, wouldn't it?
It'd be like living on a different planet. It'd be amazing, but also kind of scary.
It is a lot to take in. But I think these are the kinds of conversations we need to be having as these technologies keep advancing. We need to be thinking about the ethical side of things and the potential consequences, both good and bad.
Yeah, it's not just about living longer, it's about living well and making sure these extra years actually make a positive difference in the world.
Exactly. And that brings us to another big challenge, the whole idea of unforeseen consequences.
Unforeseen consequences, like what?
Well, think about it. With all these powerful new technologies like gene editing and AI-designed drugs, there's always the possibility that something could go wrong, something we didn't anticipate.
Oh, right. So it's kind of like we're stepping into the unknown, and there's always a chance we might run into something we weren't expecting.
That's a good way to think about it. And that's why it's so important to be really careful and to keep doing research and having open discussions about the potential risks as well as the benefits.
It's like a balancing act, always trying to weigh the pros and cons.
That's it. And it's a reminder that science doesn't always move in a straight line. There will be setbacks and unexpected discoveries along the way.
So we have to be prepared for the unexpected.
Absolutely. But that's also what makes this whole field so exciting. We're constantly learning and changing the way we think about aging.
It's like we're on the edge of a whole new era, and we're writing the rules as we go.
Yeah, and the future is wide open. There are so many possibilities, both positive and negative, and it's up to us to figure out how to navigate all of it responsibly.
It feels like we've only just started to explore this whole concept of longevity.
Yeah,
There's so much more to learn and discover.
I agree. And I think that's a good place to wrap up this part of our deep dive.
Okay, so where do we go from here?
Well, I think the main takeaway is that the quest for longevity is an ongoing journey. It's full of both incredible promise and a lot of uncertainty.
It's like we're standing at the foot of a mountain and we're just starting to figure out how to climb it.
That's a great analogy. And we don't know exactly what we'll find at the top, but it's definitely worth the climb.
Wow, so much to think about. It feels like we've, I don't know, barely scratched the surface of this whole topic. The science, the possibilities, all the things we still don't know. Where do we even go from here?
It is a lot, isn't it? But one thing's for sure, the research is definitely not slowing down. Scientists are making huge progress in figuring out how aging works, and I think it's just a matter of time before we see even more amazing discoveries.
You know, one of the things that keeps popping into my head is even if we could achieve this whole LEV thing, would we even want to? Like, what would it mean for society, for humanity, if people started living so much longer?
That is the big question, isn't it? It's not just about living longer, it's about what we do with those extra years and how it affects everyone around us.
This is kind of mind-blowing when you really think about it. Imagine a world where people are living to be 150, 200 years old. How would that change things like work, retirement, family? Would we even recognize the world as we know it?
It would definitely challenge a lot of our assumptions about how society works, that's for sure. Yeah. Think about healthcare, social security, even the whole idea of generations coming and going.
Right. It's almost too much to wrap your head around. And then there are all these philosophical questions that come up, like what does it even mean to live for centuries? How would that change our values, our priorities, our whole understanding of life and death?
Those are questions people have been asking for a long time, but now they're starting to feel a lot more, real and relevant.
Mm.
As science keeps pushing the limits of what's possible, we need to be having these conversations right now.
It's a lot to process, but I think that's what makes a deep dive like this so valuable. It's not about finding all the answers, it's about sparking curiosity and getting people to think deeply about what these advances could mean for all of us.
I couldn't agree more. And I think that's the message we want to leave our listener with today. The search for longevity, it's a journey, and it's full of possibilities, but also a lot of unknowns.
So it's like we're all on this adventure together, figuring things out as we go.
Exactly. And we might not always know where the path will lead, but I think the excitement of discovery is what makes it all worthwhile.
Well said. Thanks for joining us on this deep dive into longevity escape velocity. It's been an incredible journey, and I can't wait to see what the future holds for this whole field.
Me too. It's a really exciting time to be alive, and I think the best is yet to come.
To all our listeners out there, stay curious, keep exploring, and we'll see you next time for another deep dive into the world of cutting-edge science and technology.